Black holes are regions of space where gravity becomes so strong that nothing can escape, not even light. They form when massive stars collapse under their own gravity, compressing enormous mass into an incredibly small area. The boundary around a black hole is called the event horizon. Once anything crosses this boundary, it cannot return. Even time behaves differently near this region, slowing down dramatically due to intense gravitational effects. Some black holes do not remain fixed at the centers of galaxies. These are called rogue black holes. They can move through space at speeds of around 45 kilometers per second, drifting silently between stars. Because they emit no light, they are extremely difficult to detect. Scientists believe that there could be many of these wandering black holes inside the Milky Way itself. If one passed near a planetary system, its gravity could disrupt orbits, pull in gas, and potentially destabilize entire regions of space without any visible warning. Supervoids are enormous regions of space that contain almost nothing. These structures can span hundreds of millions to billions of light years, making them some of the largest features in the universe. One well-known example is the Eridanus supervoid. Unlike galaxy clusters filled with stars and gas, supervoids have extremely low matter density. They appear as vast, empty bubbles between cosmic filaments. Observations of the cosmic microwave background revealed an unusual area called the cold spot, which is cooler than surrounding regions. Some researchers suggest that a massive supervoid along our line of sight could explain this anomaly. Other explanations remain speculative. These voids highlight how unevenly matter is distributed across the universe. Despite their massive size, they contain only a tiny fraction of cosmic matter. Most of the universe is not packed with galaxies, but dominated by huge, silent stretches of emptiness where very little happens. A pulsar is a highly dense, rapidly rotating neutron star. It forms when a massive star explodes in a supernova and its core collapses into an incredibly compact object. Despite being only about the size of a city, it can contain more mass than the sun. Pulsars rotate extremely fast, sometimes hundreds of times per second. They also have very strong magnetic fields. From their magnetic poles, they emit narrow beams of radiation, including radio waves and high-energy particles. As the star spins, these beams sweep across space like the light from a lighthouse. If one of these beams crosses Earth, it appears as a regular pulse of energy. This is why they are called pulsars. The timing of these pulses is incredibly precise, often more accurate than atomic clocks. Because of this stability, astronomers use pulsars to study extreme physics, detect gravitational waves, and measure cosmic distances. They are among the most precise natural timekeepers in the universe. Gamma-ray bursts are the most powerful explosions ever observed. They release enormous energy in just seconds, often outshining entire galaxies. These events usually occur when massive stars collapse into black holes or when neutron stars merge. During the explosion, narrow jets of gamma radiation shoot outward at nearly the speed of light. If one of these jets were pointed directly at Earth from relatively close distance, it could severely damage the atmosphere. The radiation could weaken the ozone layer, allowing harmful ultraviolet light to reach the surface. Some of the brightest gamma-ray bursts recorded have released more energy in seconds than the sun will produce in its entire lifetime. Their effects can extend tens of light years depending on intensity. Because the energy is focused into beams, the danger depends on alignment. These bursts occur randomly across the universe, making them unpredictable but extremely significant cosmic events. Zombie stars refer to systems where a dead star becomes active again by stealing material from a companion. This usually happens in binary star systems involving a white dwarf. A white dwarf is the leftover core of a star that has already stopped fusion. However, if it orbits close to another star, its gravity can pull gas from the companion. As the material builds up, pressure and temperature increase on the white dwarf's surface. Eventually, this can trigger a thermonuclear explosion, known as a Type 1a supernova. The explosion completely disrupts the star, releasing enormous energy. The system appears as if a dead star suddenly came back to life before exploding. These events are extremely bright and can briefly outshine entire galaxies. Because their brightness is predictable, astronomers use them to measure distances across the universe. The cycle of quiet mass transfer followed by sudden explosion gives these systems their eerie reputation. The Boomerang Nebula is one of the coldest known places in the universe. Its temperature drops to about -272 degrees Celsius, just above absolute zero. This makes it colder than the natural background temperature of space. The extreme cold is caused by gas rapidly expanding outward from a dying star. As the gas expands, it loses energy and cools dramatically. This process creates an environment where molecular motion slows to extremely low levels. The nebula has a distinctive bow tie shape formed by material ejected in two opposite directions. Unlike many nebulae that glow brightly, this one appears faint because it mostly reflects light from nearby stars. The rapid expansion continues to drive the cooling effect. These conditions allow scientists to study matter under near absolute zero temperatures. It shows how extreme processes in space can create environments far colder than anything naturally found on Earth.